Oh, I think I have to make this thread safe. There's also something else that I have to do. But what was it? Yeah, this does not belong here. Because there is nothing thread local about it anymore, I think. Well, this should not happen anymore, so I think I can delete this now. And then just use an assert where the exception is currently being thrown. Or do nothing, because this is way too complex, or I don't know. wdebug, which is defined to 1 if we have assert. So this is true if graph tracker was true and graph tracker points somewhere. Yeah, the question is still, where is that being used? That's the definition. This is where I just looked at, item.h. So I want this to be done, the unregister, before before a registered memory region is set to null, I guess. Yeah, that should be it. Or is there more to it? Well, there is more to it, in the sense that at the moment I remove a memory region, it's going to print it. It's going to print the current object even, I think, which is just debug output, but still, that's what I'm trying to avoid here. Meaning that we have to do it before the virtual table of graph is destroyed, because printing means that we call this function here, which is an overridden virtual function. There's nothing, no, bullshit, there's nothing destroyed here. It's a move, it's not a destructor. That is not a problem. So something happens to orig, and then I cannot print it anymore. So I have to do the unregister before that happens, so I can still print it. My guess would be that it might happen. That's of course why I'm doing it here. Exactly inside this template. For example, the item template. If I do that item template move and then retry to unregistered, then it should go wrong. So it compiles, and then, I mean, now it runs fine. Let me run it in DDB. All I have to do is find DDB. Well, that works. And if I change this into, let's say, duplicated, comment this one out, do not do this. That was stupid. Well, no, not, because I still have it here. And then instead we do it here. So now I do it after the move constructor of item template, and but before memory region owner. And that crashes. And what happened then? What is the reason that it crashes? That, well, it was moved. So I'm trying to print something that was moved. So like I just added this comment. Yeah, it is the item template. So by moving the item template, the tracker is of course pointing to nothing. But we want to print it at the moment that it is being removed. So I have to remove it before I move it. So I have to remove it before I move it. Yeah. But maybe we can do it inside item template. Because the only thing I do here is, the only thing I need rather is the register memory region, which is stored in original. And I'm passing that to item template. So why would I do it here, right? So I could do it in item template itself, the move constructor. Make C tags. No, want to be in graph. And then jump to it. So this one could do it as well. And then the question is, of course, before what do we have to do it? Now this is more logical in the sense that it is the tracked object that has the tracker. So we have to do it before the tracked object is being moved. We could still do it because this is graph is still. I cannot do it inside tracked object itself because that is in utils, which doesn't know anything about that. But the reason not to do it here is because sometimes maybe the tracked object is not, the item template I should say, is not having a memory region. Or is that nonsense? Oh, wait a minute, I don't know the memory region. There is no memory region here. Yeah, of course. I'm passing orig, but it's also casted now to the base class, the item template. So we do lose that information. We do lose what the register memory region is, because that is part of the other base class of graph. The memory region owner. So this is the only place where I can do that. And the reason that we have to do it here is because, I guess, we are derived from both item template and memory region owner. And then you wonder, isn't there something else that is also a memory region owner and also has a tracker? I think the memory region owner itself also has a tracker. Yeah, it's also a tracked object. So it also has a tracker. But that is not accessed at the moment we remove memory region owner. So it doesn't matter that it points to nothing. Got to fix this one. So this is that. This has to be removed again. And this must be just standard move. Original. And then I'm going to do a grab sources for public, yeah, maybe namespace follows, and then some item template, and then before or after that, so probably better do a grab after that. The same thing for the, so then we have at least on one line a double public inheritance. No, that's only graph. It makes sense, I guess. call unregister memory region for the memory region stored in the second base class before moving the first base class. Yeah, true, I guess. Let's put it here and compare it then. Do it as just dot. Chat, yeah, yes, it is GPT-4 and I'm using Arch Linux. What is the name here? Current graph linker? No. No. What is it? Memory region to owner linker. That's probably better description. I want that to be a singleton, I guess. I mean, thread local is well, thread safe, and less demanding, as it were. I don't know. It didn't really give me the feeling of a global object, as in that global objects are evil. But now I will want to remove the thread local, and then it just becomes a totally globally accessible thing, which is extremely evil. So yeah, I think I'm going to use my arsenal for singletons that I wrote in the past, because I don't want to think about it, and you know, all kinds of things can go wrong, and I didn't do that work for nothing in the past, so I don't have to think about it anymore. But I don't think I want to. Well, before I delete this, maybe I should just continue this research where exactly it's being used. Though this seems to be the correct place that I want to use it in graph. And then we have it here in memory region owner.cxx. That's 3 times, yeah, well, 2 constructors and a destructor. So if a memory region owner is created for a given memory region, so this is then the base class of an owner that owns this memory region. And then that means that we want to register it passing a tracker, and this is the tracker of the memory. So it's a tracker, it's a memory region owner tracker. Maybe I should call it that. No, they cannot, because it just is. Damn it. Yeah, unclear, but okay. You see, I mean, it's not for nothing that register new memory region is called in the constructor of a memory region owner. Because a new memory region owner needs to register whatever memory regions it owns. And likewise, you know, when that is then destructed again, let's unregister it. But what is the story for item? No. Oh, that's the inform owner of. Okay. That is a different part of the API. So yeah, this part is registering and unregistering. And then for obscure reasons, graph needs to also access that to unregister something. Which maybe without that debug code we could have done also in memory region owner in a move constructor. Maybe I still should do that. I don't know. I don't know. On one hand, you would say yes. Let's, ignore debug code, unregister, register and unregister exclusively in this class. Add a debug code, add crashes, so fix it then. But on the other hand, the debug code then tries to print something that was moved, which is just, not going to do that, not even in debug code. So then I have to detect that it was moved before I print it, so that I won't print it. But what do you mean, detect that it was moved? Even that requires calling a member function. I don't want to call any member function on an object that was moved. I mean, maybe that's a wrong decision here, I don't know. But let's say we don't want to do that. Then you have to figure out more from the context of the code. Like, I just should know so I'm still not happy with that. I think I had a crash during printing before and after. But the problem should only be in the printing the before thing, if I do not print before and only after, then I still get an overview of everything. I mean, the before is always equal to the last after. So why would I print before, right? IT Relux, it's in the FAQ, isn't it? Below the video. So, it turns out that the crash in while printing the after the removal, printing an overview of after removing a memory region, was due to something else, and which is fixed now. So maybe I can go back to not printing the before, and then not doing the unregistered memory region in the graph, and do it in the move constructor of region owner. And I would feel I would feel a lot happier actually, because, well, yeah. It looks more clean. This is really hack code. Okay, dirty. Not robust, not maintainable, not understandable, not clear, I don't know, not object oriented almost. I want to put it inside this, get rid of this. So that last crash was I think we must be printing here already. I'm just not printing anything. So the last after, see the first, it should have printed this. Top actually that. Why do I not see the before printed? Okay, so now I don't want to do this here, so I'm just going to call the move constructor. Well, let me try it with a more or less. No, that's nonsense. I can just back up from Git. Just move this, then the whole comment is no longer needed. Uh-oh. And then in the, so this end sets the tracker to 0, and the memory region owner should do the unregistering, which is then here, I guess. So it was not unregistered yet. And I think that, see, this looks so much better if this works. Now this is where it belongs. This is where it belongs. Unregister the old one, set it to 0, otherwise we try to do that again in the destructor. And unregister the new one, where we move to. But then while doing the unregistered memory region, which calls erase memory region to owner, which prints this, we are trying to print something that is already partially moved, which is not allowed. And I can just not do that at all, because it's going to be equal to the last time we did the after anyway. This might work just as well. Nope, it doesn't. Success failed. That means we are trying to erase a memory region which was already removed, or what? Unregistered memory region. CC60. Oh, yeah, right. Well, we remove D, which then also remove this. So we're removing it in the wrong order. That's pretty interesting, actually. So this is the array inside D. And then removing D, I just begin with that's why I was going to say, that's why I was thinking that the move is done in the wrong order. Begin with the base class, but yeah, the base class in this case removes the memory region for the complete D, and that then also removes it for all the members. So then later you do the member, it doesn't exist anymore. I guess I should just remove this assert then. Was it? It can happen. Yeah, that works. Okay, I'm more happy with this. So we'll no longer do the unregister here in a pretty weird place. Just do it in the destructor of memory region owner. Sorry, the move constructor. But that then means that we have a problem is a big word, but you might try to erase, let's say, class members that fall into a region, or a region for class members that was already removed. I could keep them alive so that this eraser would work, but I don't care. This works as well. Okay. Yeah, let me just commit this all as well. Registration. Well then, my friends, we have again GS Okay, so now we have all the registered and unregistered things in memory region owner, and item is only calling inform owner of on those two lines. So when a member of a class is being constructed, we detect that it belongs to the class by looking at the memory where it is being constructed. And the other one is here. Why would it be in a registered memory region if it is added to the root graph? But it is for an array. An array that is a part of the root graph. I think I can even use IE. In other words, now both call it on this object. So does that make that object to be part of item or of more of item or more of no, neither, I guess. I'm just gonna make it a singleton. Definitely no longer part of item. Let me just delete this. Delete this. I don't know, just delete it and then we'll see. I think I should add it to the type of the thing. I should just add it to that. Well, at least the header. To that header. So I want this thing to be a singleton, I think. So I can have more than you can have more than one root graph, which I never have, but that's how I design it. But even then, I mean, a memory region is just unique, period. So if I make it a singleton instead of, let's say, a member of the root graph object, which I could do too, which would be more efficient if I say I had 10,000 root graphs. Yeah, still. It's, I don't know, it's kind of bad, I think, to add a singleton. Even though it's a lot more safe than just some random global object, it's still a global object. I just don't like it. But yeah, on the other hand, adding this to a graph doesn't seem to make much sense either. What does this have to do with a graph? Nothing. It has to do with the root graph. Now, if I had a special class for the root graph, maybe you could make that class root graph derived from graph, and then treat that as our singleton between quotes. Then I would have one per root graph, and then I still have to move this, root graph around everywhere so that I always can access it. And then it's suddenly a lot easier to use a singleton. On the other hand, I already must move the root graph around all the time, if you ask me. Pretty much have access to the root graph everywhere. Maybe I should start with asking myself if I have access to the root graph at the places where currently I'm using this memory region to owner linker object. So that would be here. Let's begin with item. Item as a pointer to the root graph. So So at which points is the root graph not set or known at the moment we get here? At this point. If the root graph is not known when we get here, is that even allowed or possible? Yeah, it is possible because it says here extract root graph. So it is possible we don't have the root graph yet. And I'm extracting it from the object that we just constructed it from. Yeah, exactly. If we construct a member of a class, then I do not want to be bothered with having to pass the root graph to that member you just constructed. Why? Because the class itself has the root graph. So I only need to use the root graph for objects that are created in the root graph itself. And then any object that is created inside an object that was already added to the root graph, or an object that was added to 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 the root graph, and so on, they extract it from the parent object. So in this case we have a node that is a member of a class, then that class knows what the root graph is. So the node doesn't, and it extracts the root graph from the parent. But that order must be this order, because the moment we enter here we don't know anything. So I must call inform owner of, which then does something magical that we don't know. And then only after that I can extract the root graph. What voodoo code is this? So he just looks at the parent graph tracker and then gets the root graph from the parent. This is simple enough. Well, this does not set a parent graph either. We don't have a parent graph tracker. But you see the comment here. The call to inform owner of magically will set parent graph tracker. So we'll call set parent graph tracker. Yeah, so that's a catch-22. If I hide all my memory regions in the root graph, and I have multiple root graphs, and then a random object is being created, the only way to figure out which root graph it belongs to then is to look for memory regions in every root graph until we find it, and then say, oh, root graph number 560 has a memory region that we are building in, so that is our root graph. Which then more or less proves that it must be a singleton, because, yeah, you still have to look for globally. Or I must pass the root graph manually, and I definitely do not want to do that. So it must be a singleton. We don't know the root graph at this point. And then we have the other one. I mean, I don't even have to look at that anymore, but okay. The other one does know the root graph, okay, but. Unless, of course, it's easier than that, and I can just... No, I cannot. Okay, let's make it a singleton. I'm convinced. And it's going to go into this header file here. This now must be a singleton. So we type in singleton, and hopefully it turns green. Yes, it does. So I can jump to there. This is my old utils singleton file. Hopefully it has a documentation in it as well. Apparently it does. Here's the documentation. Usage. My singleton. It must be derived from public singleton my singleton. Oh, well, let's just copy everything. Easier than remembering it, unfortunately. Substitute my singleton with memory order, memory region to owner linker. And I need to have a private default constructor. Seriously? Thank God we don't have any constructor yet. Okay, this is 100% a real singleton. As in, if it compiles, it's a singleton. That was defined in utils. I hope. Think namespace. No. Apparently not. So I just put it in global namespace. Back in the day, right? Utils singleton. Now what I don't know is if this thing is even thread safe, because I was also going to work on that. I think it's one of the first things I have to do now. Finally start to think about the thread safety of this thing. So is singleton thread safe or not? I think it's singleton. I call instance, for example, that returns this instance, global instance, probably this one. That does returns a reference, so that is thread safe, except this, of course. Oh, that's just if dev debug global. Yeah, that's totally thread safe because it doesn't do anything. I should look at the instantiate, I think. But instantiate should only be called before main, isn't it? Which means that there are no threads. It says -1 on initialized. Doesn't look thread safe at all. Initialize is static hard, not even an atomic. But yeah, I mean, instantiate should be called only if you only from global constructors, which is definitely being called before main, and then they may also be called after that. In which case, this is yeah, never true. So we can drop always here, and it's the same thing as the instantiate. Sorry, as the instance function. So that would be thread safe. Now I'm doubting a little bit though. I mean, on Intel that's no problem whatsoever, but I think that officially nah, we have other synchronization things in between. So it's okay, that's not an atomic. So it doesn't know about anything about threads, but it should be working in a multi-threaded environment anyway. But then, of course, we have this standard map, and we can never, ever, ever, ever access that at the same time by two different threads. So we should make that one thread safe. But okay, let's first finish the singleton. Now, I should not have any global object in the first place. This is always done after main right here. So this is just an instance of whatever I just made. I forgot the name, of course. Something with linker. What was it? Memory region to owner linker. It's green, so that should be the one. Yep, that's my singleton. Graph linker underscore, that's the other one. And then we have a problem in memory region owner, of course. .h. Nope, that one. Yep. You substitute in this whole file something with that globally. That is something is that. Error, attempt to use deleted function. Uh-oh. instantiation of function template specializations and a destroy add blah 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 blah. I'll probably destroy this. Request it here. And instantiation of function template specialization. Request it here. And so on. Requested. In instantiation of member function standard map. Oh, what? Yeah. Oops. Oopsies. Yeah. Oh, yeah. Right. I made it a singleton, and that means that I cannot put it in a map. I need one thing to be a singleton, but I also need to be able to put them in a map. Other objects. Sure, that wasn't quite working. Now what is a singleton? Well, the singleton is just where I access the singleton, I guess, but I don't know. Let's see. Grab sources for that thing. Bool void debug boot void something void comments blah blah blah. Header file singleton stuff. No, includes instance. I just need a different class. Ridiculous, but true. Yeah, I have to make it a singleton that is derived from this class. And I make it impossible for anyone to access it, except I guess memory region 2 owner linker. Okay, I had some documentation on how to make a singleton that is derived from a large base class. Didn't see that here. Pretty minimal. At singleton, I have global. Maybe that's where it is documented. Merida. Take a break of 10 minutes. Have a cup of tea. And then start afresh. What also helps is making a cheat sheet. Don't bring the cheat sheet to the exam, but while you're making it, you can tell yourself that you will do that, and then at the last moment you don't do it, but totally helps. I mean, I did that, and it's just the cheat sheet that you make gives you a feeling of peace, you know, like, okay, as soon as I write it down on my cheat sheet, I have it. It's there. I will know it. And then I take this cheat sheet with me to the exam. Now I can concentrate on the next chapter. And in the meantime, you force yourself to make a nice summary. And yeah, you remember it anyway, because cheat sheets are very short. In the end, you will remember it anyway, so you don't really need to bring it. And then, yeah, it helps. Oh, the feeling it's not really documented here. Don't even have a link to it anymore. Gotta be kidding me. Well, if it exists, then I suppose I'm going to find it. Yeah, there it is. Just no link. The darknet. You have arrived on the darknet. There are no links to this page. Global objects. Singleton base classes. Blow this up a bit. Okay, so I can have a base class as long as it does not have static data, we can have a protected constructor, and then we are fine. If it has static data, then I must have a private constructor and can just add a friend for the next class. And this stuff only goes into the final one. So just protected is okay. Well, I don't have any static data. Right, though that means, let me move this down then. Let's put that there. The singleton. What the hell? I need to give a new name to one of them. So none of these things derived from singleton anymore. Maybe that is defined afterwards. Oh, that's why. That's why. This is the design, as it were, and now we get a singleton template with the final and a child. The default of the child is final. Should get another example then. Yeah, here it is. A template class final B1 public singleton final B1. This is what I need. Apparently, and then it can derive that and then pass itself to the friend class instance. That's a friend instance, I think. My God, I need a name of this thing. I mean, I could just add singleton here. But it's starting to be a little long then, right? No? Okay, not. So let's use this then. And that must be derived like this. Just pass itself on to the base class. Recipe coding. We don't know what we're doing, we just follow the recipe. Singleton. Well, yeah, then there is still a problem, because I'm pretty sure that this thing is now completely inaccessible. Well, I definitely did not want that. It's derived from singleton. I don't want it to be a singleton. Maybe I didn't do the right thing here. This is what I was looking for. Singleton with a large base class. Yep, that's what I wanted. So just a normal class, public and everything. Yeah, I was an idiot. This is what I wanted. So you can just add a tag. You just can just tag along some class. It's still a singleton then. Duh. Yeah, okay. Region to owner linker singleton. What am I doing? Well, that compiled. I guess we have a real singleton now. Let me try running it again. Crash, crash. What the hell? Before? How did that come back? I deleted it. Or do I have another one? Oh, we have two of them. Let's try deleting that one as well then. Still segmentation fault. That's interesting. I didn't change anything except making that thing a singleton and it starts crashing. Wow. Okay, that's shocking. Construct an array which is derived from array memory region owner. So that's constructed. It's derived from memory region. Wait, array memory region owner, which is derived from memory region owner. It is therefore constructed, which calls a memory region to owner linker singleton instance. which is the memory region 4. Where this pointer is a utils internal global base CBB graph is memory region to owner linker singleton -1 instance. Standard map. Memory region to owner as key. Memory region to owner linker. Try and place. Memory region to owner. This is singleton. Instance. Just that pointer. Unique. I think I made a mistake and I have no idea what, so maybe it's time to, after all those years, to try to turn on debugging, global debugging. I always turn that off. Let's turn this on. I think we get a problem now. Probably have to, no idea, resource, configure, to enable debug globals owner, make. Doesn't work because reconfigure libcwd with. Yeah, I guess that means I just have to edit this. lscmake slash git blah vi. libcwd must be also be compiled with, well, it just told me, right? These two are being turned on. No, wait. Please configure with disable debug global. Oh yeah. Or reconfigure libcwd with enable alloc, enable location. So which one is turned on then for these two? Oh, this must be turned on. It's good that it tells me, because I wouldn't have any clue. Like seriously, no clue. Does not match generator used previously. Unix make files. Either remove the CMake cache. Dude, what are you talking about? Can't lock. Oh shit. I'm completely lost. Optic dash CWDR. Config hash is 6AF80. I don't have that, so just make it, thank you. Why wouldn't it not do that? So apparently there is a CMake cache text somewhere in here, so it cannot rebuild it. Well, I'm very interested to know if that is the case, but it should have worked without that, without me doing that. Maybe it tries to reuse the build directory here, or what the hell, man? Let me just remove both of them. See if that fixes it. And then I have to remove the lock again, probably. And let's try running make again. Or configure, I mean. Well, that helped. That did help. Wow. Yeah, it should have automatically removed the CMake cache. I think this is ridiculous that I have to do that. Or maybe run make clean or something like that in that directory. Okay, so now we have a new install. So now the root is set to that. So if you do ls gitash got that thing done, it says that it was configured with alcohol. Now I should be able to do a make. And this time it worked. And now we have debug a global what is it? Global variable debugging turned on. which of course only works if you use my utils library for global objects, and in this case singletons. And that should tell me if I did anything wrong in that, on that topic, or undefined symbol. Oh, it's linking with the local install. What the? Seriously? Why? This is so broken. It should never ever ever do that. The only reason that, oh wait, actually it should do that if I am so stupid to set an LD library path. No, no. So who did set that? Yeah, that doesn't work with Gitash unless you do something guru-like, and I know what, but I think I should rather find out why this was set, because I don't want it to be set. So who is setting that? Didn't get set here, maybe here, or otherwise, you know. It's not set. Here it is set. Yep. Compile nth. That's not good, man. I guess his compiler, set compiler environment should be a little bit different when it detects that I'm using Gitash, because Gitash doesn't like if LD library path is being set, which automatically means that I cannot use this install prefix to begin with. So it bites, as it were, or I should not have libcwd installed there. Yeah, shall I add intelligent stuff like blah blah blah, check check check, and then print oh wait a minute, you're using Gitash and you have libcwd installed in your prefix, so that's not going to work. You know, because somewhere in the future I'm like way more senile, and then I will have no idea anymore what to do. So it might be smart to write something that tells me what's going on. I think though if I do this and even that, I'm not sure. I'm pretty sure Gitash will use Gitash. But they changed something in the what is it called? the bin tool bins, bin tools, objects, I don't know, something tools. It used to work and then I broke it. Let me just unset this. Or I should remove it. I don't think I have installed that much in it. Oops. ls lib. Yeah, the only thing in it is libcwd, which you always put in guitars. But yeah, I don't know, maybe I'll just remove it for now, I think. Root. I want to remove everything in this directory. Okay, now it runs, it links, and it tells us what we did wrong. Using instance in global constructor. Use instantiate inside the constructor instead. Or add instantiate to the constructor before calling the function that calls instance. Where instance wasn't called directly by the constructor. Up, but it says using instance in global constructor. I don't think so. I already entered main. So here I'm constructing an item. This can't be right. I mean, this is we are already inside main. Maybe it did not detect that we entered main already. That's possible. Yes, we are. To this call to init should do this. Main entered. And the question is, do we get here? Let me put a breakpoint in debug.cxx line init line 235. And then run. Next. Oh, now I'm at 287. I think something went wrong, right? Minus. What the hell is this? Where does Enet begin? That begins. If the debug global, I don't think we got here. Debug all the log, is that it? Should, all this stuff should be defined, man. Come on. So is that a breakpoint on, let's say, 246? Yeah, it sets a breakpoint at line 287. So this is not defined. And therefore, it doesn't know that we already entered main. Bad. Why is that not defined? And neither is this or that. Use libcw. Jesus Christ. Oh, and use libcw. Okay, we're not using libcw. Memory leak filter stuff. Yeah, well, not sure about this anymore, but oh wait, no sync with this is now for the default, so we don't have to do this anymore. Interesting. Didn't know that. Anymore, I guess. Okay, so the question is, why is that not defined? Who should define that? I think libcwd should define it in the config file. If we which is the new one, I think the top one, 6A, F80 and so on. Yeah, I have something in my mouse buffer. Let me put it out. Sure, this was the right one, right? Done. To enable libcwd alloc is on. Yep. Nah, bullshit. Global is not part of this. What am I doing? It's part of utils. Oh, is it global? To config. Debug global. And apparently that's not defined. That's really weird. Really weird if that's the case. Let's hope that's not the case, because that would be really weird. Yeah, I'm sitting in the dark. I really have to turn on the light here, as usual. Utils, config, what? I meant, of course, object here. So this thing should be included. And then we see that it is defined. So the problem is that it does not include utils config.h. Why? It really does not do that. Ridiculous. We are talking about this file. Or not. No, we're talking not about this file. This just includes init, which is defined in cwds debug.cxx. So we are talking about this file. And this file includes sys.h. Okay, who changed that into angle brackets? Is that what I want? That should include this sys.h. I doubt that it is doing that. It doesn't matter. I think it is about that one anyway. So if it includes that one, it includes this one, and if it includes that one directly, then that would be okay as well. cwds sys.h. And that should include utils.config. But it only does that when have utils config.h is defined. So probably that's not being defined then at the moment that cwds is being compiled. Yeah, it has been so long time since I tested. I think even I never used the whole global thing or the singleton thing. Since I use CMake even, so it's like totally not tested. It's entirely possible that while compiling cwds, it doesn't define this. Let's highlight it. So normally that is defined, but was it also defined while compiling libcwds? No, it wasn't. It's defined while compiling utils. It's not defined while compiling CWDS. Why not? Okay, so who's defining that then? Who's adding that define? Type file execute grep HNS, that thing. Ridiculous. Oh, that is only defined when you link with utils. That's a bit far-fetched, isn't it? Is CWDS not depending on utils these days, or not? Almost hope it is. Include util singleton. Totally. What about the header files? Oh, look at that. Here, has print on. Utils config. Wait, that would be interesting. Yeah, that's probably that exactly the thing that I wanted it. Yeah, hello. Instance tracker as well. I think you can hardly get around it these days. CWDS depends on utils. Yeah, literally, like always, if you include this error, that is tracked usage detector. Utils array. Yeah, here it doesn't say that it is depending on utils though. It only depends on CWM4, it says. Oh, we have a comment here that talks about what I am investigating. CWS depends on utils if disable global debug is not specified and utils exist. Well, that is correct. And that is missing in the CMake stuff because that is auto tools. No, can you understand this? M4 if CWM4 submodule dir name something append unique CW submodule subdirs utils. Pretty sure that this is what I want to do. It doesn't check if disable global debug is not specified at all. It just adds it. Strange. Is that a generated file or something that only gets generated when? No, I don't know. Anyway. Let's try to make that work on CMake, for CMake. Dependencies, that means that we need to add a dependency on utils if and then that condition. But I'm not talking anymore about if disable blah blah blah. I can just check the I can just check the if option stuff exactly like that. I don't think it matters where I add it. Let's put it here. If option enable global or something maybe. What is it? Nobody knows. What was it called? Oh, we print that out when it run configure. Yeah, enable debug global. That's what I wanted. And then with option front option debug global. And then we add the target link libraries for utils. Don't even have to check if utils exist. I mean, don't define that if it doesn't exist, I would say. Gee, that's probably something like AICXX colon utils. If it works, then that was it. Yeah. Nothing to do, not good. Maybe, I don't know. Let's try make clean. No, still not defined. What the hell? No. Do we get here? Message status. We get here. Nope. Oh, that's because CWDS is configured before we even get to the option. That option is defined in utils. Oh, right. Yeah, no, I could configure utils before CWDS, then it would work, I guess. That's kind of ugly if that is required. Plus, I don't even have control over that. I think that is being done in one of these include files. Probably this one. Type F. No, not really. I wanted the file itself. Actually, that looks like a thing. What if I do utils before that? We cannot do that because you have a circular dependency now. CWDS depends on utils and utils depends on CWDS. Well, it does print we get here, so victory. Yeah, but it doesn't work. You cannot have one depend on one and the other depend on the other one. Apparently, so let's keep them in this order. Think of something else. It's not where I wanted to go. That won't work. I need another trick to find out at this point if I have that file. I think I should just check if the file exists then. It won't exist yet actually, because we're just configuring. Yeah, no, it won't exist. I can maybe check. So this is not defined yet, but I can check that. So bright. Yeah, but it's that easy. Could have guessed it. Oh, I could have guessed that. I just have to remove the option basically and then enable debug global. That's it. Okay. Let's add a comment. This wasn't set as option. Because LDS is configured before utils. So CW option wasn't for this option. Wasn't called yet. We get here, okay, and no error. What? Okay, that's strange. No, it works. Now it compiles CWDS with have utils config.h. So I could make it cross-dependent. Let's make a small change first. I could also, of course, just have defined it here myself. I mean, maybe this is a bit too much, right? On the other hand, I don't know. Some other stuff is also using utils. Yeah, see, alternatively, since it turns out to work anyway, I could just add this dependency always here. I'm surprised that it doesn't complain. I mean, if I did it the other way around, it was complaining. No, yeah. For now, I'm gonna leave it like this. So I don't really like the dependency, so I just leave it out unless, yeah, in this special case, I don't know, whatever. Oh, I did something wrong. Okay, so I make clean. See if that really works. It works. Okay. What about running it now in the debugger? There is a faster way of this, right? And I blinked without stopping, but it went okay. Run, and we still crash, but now it says missing global static initialization of singleton instance. We graph is memory region to owner linker singleton. There should be one and only one code line reading static singleton instance we graph with memory region to owner linker singleton dummy. Oh, and I didn't add that. Sorry. Copy. So there's lots of work, but in the end, we call it the work. Call it the work, and this kind of output is beautiful, isn't it? I mean, I wrote this like I think more than 10 years ago, maybe even 20 years ago. While I was still smart, and it just really digs deep into what all the possible errors that you can make and checks it and then tells you what you're missing. So that's pretty beautiful. And yes, this is what I was missing. I kind of understand it and therefore now realize how stupid that was. Okay, so memory region to owner linker.cxx. You moron, you didn't instantiate it. Actually, it should be instantiated outside of this namespace, shouldn't it? I think so. But you can I get a collision now with another dummy? I don't think so, because it's static. It's good enough. Make run, and it works. Good. Cold Z, I have no idea because I never used Rust. I'm not a fan of Rust, but it's for obvious reasons that I dedicated my the larger part of my life for to C++, and there is still a very large community for C++. Very renowned people that put also the whole life into it in making it better and better. New standards come out every 3 years. They keep improving it and improving it and improving it, and then suddenly someone comes around and says, "Hey, I have a replacement for C++." Bang! And within 1 year, people are convinced. So either the hundreds of people that work on C++ to improve it every 3 years, they are non-stop working on improving C++, and they all missed what Rust has been doing, apparently. So yeah, but I don't have a real personal opinion on it because I never looked at it. But I'm like, yeah, if they really made such an improvement, then why didn't the C++ committee do that then? They must have had a reason. But maybe it's something brilliant that is absolutely improving the language, but so not backwards compatible with C++ that it just simply cannot be done in C++ itself. It's a really different language. Okay, so now I turn something into a singleton. Get status, get commit, turn into a singleton. And that will be it for today, because it's late and I'm going to do something else before going to bed. It was not really much progress, I'm afraid, but okay. So next I should work on, I think, making a thread save everything. Can I already understand what that involves? I guess all the graphs might be shared. Access to graph trackers is shared. So a lot of shared stuff. Yeah, I can begin with making this one thread safe. This map. I'm gonna do that anyway, not right now, because I want to. So the way that works usually is you say using memory to owner map. type. Is that? Well, then this can become. No, not no. Oh, map type. Yeah, it's a map, but it's. I want to. Bleh, what the heck? I want the word container in it. I'm gonna call it container type, but then you have the weird name. Memory region to owner map container type. Ouch. But it's not. That's how it is. Okay. Then we do a using, and then without a container. Which then is AI thread safe. Wrapper. And then that thing. And then I think AI thread safe policy. Why can I not remember that? Unbelievable. I just have to look in another project, I think. What? Undo. Redo. Yep, let's use primitive. AI thread safe wrapper, and then the container type, and then AI thread safe policy. So it should work. Policy primitive standard mutex, something like that. Okay, I have no idea why these things are not green. Oh, because if I include this, I need a new submodule, thread safe submodule. Okay, let's add that. Yeah. Repositories. Memlink. Your block task is all task REPL. AI thread safe. Adding. If we run configure, now it should say that it configures it. Grow utils, nothing. What? Oh yeah, just no configuration required. And then I can do make, and then it should build it. CWDS is compiled, and we fail on use of undeclared identifier AI thread save. Yeah, but it's because I didn't add the header yet. Now it's green, so now we can get the header, which is thread safe, blah blah. Let's add that. And that is not a capital, it's a lowercase policy. Error no member named empty in AI thread safe wrapper standard map blah 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 blah. Yeah, that's because it's thread safe now. Can no longer call empty, which also shows that this is not thread safe, because you can call empty on it whatever you want, but as soon as that returns something, it might not be empty anymore, or the other way around. It's a fuzzy thing here that won't work. Oops. Problem. So there is a problem with it. Let's remove it and try it again. Find. Okay, so we try to access this thing. And I'm finding it, and then if I find it, I erase it, maybe. I guess it's pretty safe to just not allow anyone else to mess with this while we are doing this. There's the whole erase thing. However, we have a recursive call, but that's on a different memory region to owner linker, so also a different map. I think it should be possible to just, block it. So we make an accessor now. We have this. That's a type, and I need read access for the find, and then only if we find the write access. But I made it primitive, so it's not read write access. Might as well create a write access, and then I'll just call it W, and we create that from this thing here. So that logs a mutex on that map, the mutex that we added, and then I can access it by using W arrow. And then we get the same problem in another function, so I have to do the same thing here. This is a find inform owner of, so I don't think I need write access here. nor there. Do kind of the same thing. I have this variable type read access type or thing, and we have the mutex logs, and then I can get read access by using R arrow. And trust me, the whole world should be using my library, because this is way better than messing with mutexes yourself directly. If I wasn't such a coward, I would change it, or try to get it accepted, I guess, by a boost, and then eventually get it into the standard. But yeah, that would cost a lot of time, which I would even be prepared to put into it if it was accepted. The coward part is that I am afraid that I won't be able to convince people, and then in the end have wasted another year of my life, and without it getting accepted anyway. So this gets read access, and then we get here a const pointer, but you can call find, of course, on a const map and end as well. Oh, there is one more, and this needs try in place, so that needs write access. Now, because the policy here is primitive, aka I just add a normal mutex, standard mutex, there is no difference between read access and write access. In both cases, you just lock the mutex, blocking everything, other readers, other writers, everything. But the syntax still tells the user that you're, you know, having a write access here. And in the case of the read access, you cannot do a try and place on an _r, because it's read. You only do get const access, even though the mutex is yeah, the same as for the write access. And it is it's pretty easy. You know, I code it like this, and now I can just change the policy to read-write log, and it would still compile and work. And then suddenly the read logs would not log out other threads that also want to read. So you could do concurrent reads if you want, without having to change the code except in a single line. Sorry, there was a W. That is the last one. Of course, it is the last one. Wait. Key value pair? Why would I need write access here? So I'm just printing it. Let's go for read access. In fact, it's const read access. You cannot convert this one to write access because this is const. So this is const, and then you can only get a const read access. The other read access can be converted to write access at some point. This is, and of course, not allowed because, yeah, it was const to begin with. And maybe that's also the case for the other read access thing that I made here. Yeah, there's also const. So I have to use cred here. Oops. No member named memory region to owner map W in linker. Just yeah. Oopsies. This is in second, so I have to lock that one separately. Or you can just log it in line as well. So you just create a what here from that thing. Where the what is this? Now you can ask yourself, is it necessary to keep this write log while I'm doing this? Because this is another container. No, it is not, because the IBP contains the iterator to that thing. So we find it. We do a try and in place, and then if that is succeeded, we have an iterator into this map. So you need to keep the log. Even while then we do something on another map, but that's actually a map that is a member of an element of this map. So we have a whole cascade of mutexes that must be logged here. Well, 2 in this case, but yeah, just 2. The main power of this library is that it forces you to log the mutex. It's just completely impossible to end up with something that is not thread safe, that you forget to log something or something. It is not accessible anymore unless you tick the log. So you don't have to think, you just fix all the compile errors and then. So to have got this one, so therefore it does not compile. In this case, we have a reference to a memory region to owner linker, which is again an element of what we just found in a map here. So we keep this log, and we need temporarily another log on the element map to access the empty, to call empty. There's no way around it. So I'm just gonna go for the I think this is also const, right? So we need again a cred here. Actually, we still need a log here. So here, let's put it at outside. Let's make a cred here. Memory region to owner linker, that's something else with that one. As long as it wasn't used already. So I guess that works. I want to unlock that one. Okay, read log it and then use the R here, and then we can also use it here. Just keep the lock. Keep the lock while you do the empty, and then do that one. So only lock it once, and then we unlock it again here on the brace exit to scope automatically, of course. No memory name print on with indentation in standard map, blah 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 blah. Okay, what did I do wrong now? Which constructor for initialization off? It's getting later and later. I wanted to stop actually. Why is there suddenly so many errors? Yeah, I'm an idiot. It's not true what I said. And this can just be this can just be whatever it was. It doesn't have to. I don't need a lock on this. The lock is internal on the map. Slightly confused though. I get the memory region to owner linker object here, and then I call empty. The thing doesn't even have an empty. Oh, that doesn't have an empty because of this. Right, I deleted the empty. That was the reason. Yeah. Oh, sorry, I got confused. But yeah, the reason that I commented it out is correct, because we do need to keep the lock, I think. You cannot just call empty, temporarily read log it here, then unlock it again and return the boolean, because then a boolean might be fuzzy, not work anymore. In other words, suppose I call this and I do the lock internal inside this empty. So what the changes that I made were nonsense. Sorry, this is not true. I don't need to do this at all. So we add back this member function empty and it returns something, then it is possible that when after I return, the value changes. The value of the empty changes. That is only if another thread could access this object. and get write access to it as well. And I don't think that's possible, because I'm pretty sure that we only try even to get read or write access on an element while having locked the parent map. So this blocks other threads. I mean, since it is simple mutex, it blocks all other threads from accessing this map, and therefore from accessing the child map, as it were. So this is not fuzzy anymore. And if I ever would turn it into a read-write lock, then this blocks writing at the least. So other threads could still read it, but reading is reading. Then also the elements can only be read, so it would not change the state or the whether or not it is empty. So we can simply check that and then continue as if the returned boolean is well protected by this mutex. Nevertheless, I don't really like it. What I would normally want to do is say get a lock on it, then pass the lock to empty, and keep it, while we call this. And also pass it to that, I guess. How many points are calling this function? If this is the only place, then that would be a good thing to do. Oops, yeah, well. Now this function is not only called from itself. So who is calling this? Maybe this one. I guess this one. This is the recursive call. And this print on is a member of. Yeah. Which indicates that really I should have wrapped the whole memory region to underlinker as an AI thread safe thing. Then you can just lock this object, and while having locked that, call stuff like empty, and then print it, and so on, and also lock it and then call print on passing that lock, which then passes it to itself and then recursively keeps the lock, which is way better than what I did now, right? Just locking the map internally. Nah, actually not as good. Not to mention that this thing occurs also there, which is therefore a part of that. So it can literally hijack then the mutex of the parent map. Just take the mutex once, and then we have access to that map plus all the child maps without having to lock another mutex. So that means that I have to wrap my singleton. Unfortunately, if you call instance, you'll get that clause. That makes things very, very difficult to paint suddenly. Maybe I can do singleton and then wrap this. I don't know if that's possible. How can I make a thread safe singleton like that? Well, it's totally new to me. Yeah, or we need another clause again. We can have the instance. Yeah, I don't know. Yeah, I guess make this, the factor there was about large base clauses, right? I think that was for when this is a template. So then you can have a large base clause that's not a template. But I might as well, and that's probably even more logical, turn this thing into a member. So then the singleton can just stay itself, and the member then is should be wrapped in AI thread safe. And then instance returns something that I still have to lock then. So I can get the instance and then take the lock. Yeah, I'm going to do that tomorrow because it's getting too late now, so I'm going to quit.